Okay. Is the screen visible?
Yes.
So we'll start with prescription processing, then we can do weight measures and the calculations. So prescriptions, we all know what prescriptions are. Basically, it's like what an order or instructions given by a prescriber to a pharmacist on how much of what to dispense to who, and it tells the who how to take whatever is prescribed. So prescriptions, it can either be for drugs that are already like compounded, like someone needs paracetamol or something, or it can be now you're supposed to make something for the patient, like extraneous compounding, then you dispense to the patient. So basically that's it. So a prescription is basically an order for medication issued by a physician, a dentist, or any other licensed medical practitioner to a pharmacist, telling them what to dispense to who, and for the who, how to take it. So basically that's just about it. And then now, I don't know, now let's, for example, just look at an example of a prescription. Say when you get a prescription like this, you're supposed to first, before you dispense, you're first supposed to verify the prescription. So you will of course check if the prescription has the details of the prescriber, the details of the patient, and so far and so on. And then if for prescriptions that need someone to dispense, let's say controlled substances, then you need more than just like the name of the prescriber or the facility from which the prescription is coming from. You'd need, let's say if it's here in Kenya, I know people have those numbers, I don't know what they are called, the numbers that you can use to identify a specific prescriber. So then you can be able to know if they are licensed to prescribe those controlled substances. But anyway, yeah. So this is an example of a prescription. Yeah, there. So like we said, it needs to have one, the details of the prescriber. It needs to have two, the details of the patient. It needs to have the date, so that if you need to do maybe a number of refills, then you'd be able to know how to do the refills and when to stop doing the refills. Because if it doesn't have a date and you expected to do like 3 refills, then how would you know you have actually reached the 3 refills? But if you got a prescription like this one for January 9th, and you suppose you need to take a certain drug for every time a week. So the first 1 week, the second 1 week, and the third 1 week, you can use the dates to, at least the other one is part 4. Part 4, that thing that is always there in the prescriptions, the RX thing. Yeah. So RX is that one you take or something. It means something else that you take. Oh yeah, we'll also look at some of those abbreviations in Latin things. So RX means you take. So that's the superscription in a prescription. So you start with the superscription, the RX, then you go to the number 5, which is the medication prescribed. That is the inscription, number 5. Then number 6 is the subscription. So number 6 basically tells the pharmacist how much of what to give. Then number 7, it's the called what, signatura. Yeah, that one gives instructions now to the patients. How do they take the drug? You take like a tab every day or such. Then some of them come with number 8, which is a special instructions. So they either tell you the number of times to substitute, or some will say, no, the number of times to refill the prescriptions. Some will come with instructions, like don't substitute and such. So basically that's it for the parts of a prescription. Then I think I saw a question that was asking about parts of a prescription, but now in that question, it didn't ask about this, the common parts that we know, or the ones I've talked about. It asked about, I think it was what, I don't remember, prefix or pre-something. Those are the now, I'll see that question when we're going through the paper. It was asking about either prefix or something like that as a part of a prescription. So that's basically just the part comes before the actual prescription, like those details of the prescriber, the date and such. Yeah, so basically that's parts of a prescription. Yeah, so basically that's it for prescriptions. But then now for you to be able to actually interpret and dispense whatever is written, you at least need to know some of the few Latin words and some abbreviations used. So we look at that, then we do now calculations. Yeah, so there are just many more examples of those calculations. You see, like, for example, in this prescription, you're supposed to give propranolol 40 milligrams. This means oral 4 times a day. So then if, again, you don't know those abbreviations, again, it becomes hard. So PO is oral, QID is 4 times a day. Q means, when it's Q alone, it means every, like, maybe every 4 hours, every day. In this case, it's every morning, AM. Yeah. Someone tell me what HS means before we get to those other ones.
HS is bedtime.
Okay, I'll check. I can't remember that one. PRN is, of course, as needed and such, or when needed. So we'll now look at those. But as long as you know the ones for how to give once a day, twice a day, those ones, you need to know those ones. Then guys, if you can't hear me at any point, just tell me. My internet is not the best.
Have you heard? Can you hear us? Sarah?
Yes. Huh?
I think I've heard guys saying that HS for number 3 means bedtime. I've had my own things. Guys, please correct. Come on. You see the one you are looking for, HS, before PRN. Nimesikia ni kama ni bedtime.
Okay, yeah. So yeah, but basically what are they called? Yeah, the ones you need to know the times, like what time to give or how many times to give. And then if it's night or morning, those ones also have those Latin words. And then also for those ones before food, after food, then ears, eyes, drops, those ones. But let me just go there. We do them then. Yeah. So we need to, of course, know the symbols and abbreviations so that we don't misinterpret or even cause those errors during dispensing. So, yeah. So basically here, what they are saying is, if you're writing, like if you have zeros in whatever figures you're writing, then you only need to write the 0 if it is significant. If it's not significant, then unachana tu nayo. Because if you write 4.0 milligrams instead of 4 milligrams, then someone might just end up missing the point and dispense 40 milligrams. So in that case, you don't write the 0. But if the 0 is significant, for example, in like 0.4, then of course you write the 0, because if you just write 0.4 milligrams, again, someone might miss the point and dispense 4 milligrams. So if a 0 is significant, always write it. If it's not, then you don't write it. Then when you're writing like kama milligrams, as much as it is 4 milligrams, you don't write, if you're writing in like the symbols mg, you don't write with an s like milligrams hivyo, unaandika tu hivyo bila hiyo s. And then if you write, then if whatever you're dispensing ama chenye unaandika has not now like milligrams, but the unit is those ones like units, 100 units of, it's much easier to write, not much easier, it's way safer to write units instead of u, because again, with these band handwritings out here, you might just mistake that u for a 0 and then again end up dispensing the wrong thing. Yeah, so those are some of the things that might cause, what are they called, those dispensing errors. Now here are our abbreviations and what each of them means. So for example, the second one, AD, that one is important. We'll see it when we are doing calculations. You are told put 5 grams of a drug, then add to make this and this. So sometimes they'll not use add to make up to, they just write AD. That is important. Or instead of saying add to make, they'll use this one, QS, to say add to make sufficient quantity or to make, yeah. So they can use AD, QS, or QSAD now to mean those ones, like add this amount of water to make up to, or add a diluent, something like that. So those ones are important, I think. Lakini msome hizo zingine, please don't say I said they're not important. Yeah. Then on this other side, AC is important, the one for before meals. So if a prescription is written, you take something AC, then it means before meals. BID or BD, is twice a day. Then some will just use D for every day. H or HR for an hour. Then HS is here at bedtime. So before meals is AC. Between meals is IC. Then after meals is PC. So yeah. So before meals, after meals, and during meals or between meals. Those one are important. Then also this one, for some of those drugs, instead of them writing like take every night or take PM, then they write knocked. Then that means at night. That one is also important. Then NPO or just PO, that is by mouth, oral. Then PRN as needed. Q is for every. So if you see Q, then something after that, it's every, then whatever follows. Then QID 4 times a day. TID or I think TDS 3 times a day. Yeah. Then these other sides, of course, you'll see some prescriptions with body surface area measurements, especially when you're dispensing for children or the geriatric population. Then most of the prescriptions comes with body surface area because you have to calculate how much drug they need for that. Then fluids. Then this one. Guys, can you see my cursor?
Yes. Hebu songesha.
Kinda.
Oh,
Yeah, then this one for drops is also important. Then of course these ones for units, those ones I hope mnajua. And then for the unit, you also need to at least know how to convert the basic one, the basic units, like from milligrams to grams to kilograms, those basic ones, because they'll give you questions having mixed units. Then you need to convert to at least a common unit before you calculate. Gani ingine, which one of these ones is an important one, my people? And start is here. So start immediately. SOS is if there is need or as needed. So it can be used either SOS or PRN. Then it would mean the same thing. So I think mambo ya prescription na abbreviations na those other things inaishia hapo. So unless mtu ako na swali.
kunayo ile ya ears. Right
Hiyo
ear,
ya
left.
ears. Oh, those ones
Kuna
for
mtu
ears and
ameuliza.
eyes.
Oh, yes.
Okay, so
We've
let me
got
just see.
AU, AL.
If it's not in this table, I'll find another table that has those information. Medication. No, it's not. Let me.
Okay, ilikuwa AU was both ears.
AU was for, yeah, so those instructions like AU means
Both.
both ears.
Yes.
AD is right ear. Sindio, Diana?
Yes. Then AS left.
Left then. Okay, let me find another one that has those ones. Maybe another table. They're here for routes of administration. Yeah, so AD Yeah, so the question was asking, you get a prescription written. You see, we've seen there on the other table, drops is GAT. So they're written GAT, something, something, then AU. Then they were asking what instructions should follow that prescription. So then if it's that, then at least the instruction should be something like for the ear or do not ingest, something like that. So yeah. So for the ears, then for the eyes, they are here. So right eye, left and both.
But I've seen that most prescribed they don't write like right ear or left ear. They'll write BE, so that's like either both ears or both eyes. And if yeah, it's mostly like that.
Okay. Something else, my guys. Ongezeni points zenye mko nazo.
Also this PV, the
Oh,
last one.
the
Yeah.
last one. So
Yeah, that's I've seen
that one. Yeah.
Seraphine, kuna
Yes.
venye unaweza differentiate odi ya once a day na
Ati?
ya right eye. Odi ya once a day na right eye. Ama ita
So,
depend tu na prescription.
I think ukisoma prescription, then when you see the context, like if they are saying something like what? I think the context would really differentiate, wanamaanisha uweke kwa right eye ama upeane once a day.
Okay. Ama the drug. Sawa, sawa.
Yeah, so either ukiona, yeah, or I think the context, because if let's say like what? Please nipe example, letting.
Tabinafil. Onychomycosis. Umeze once a day. Something.
So unaona kwanza kwa hapo itakuwa tablet. So definitely ukituambia mambo ya macho atawekwa na jokes, but I also think now if it's like for the eyes, then kutakuwa na either something like maybe drops, gut or something else that shows you, hey manze, it's not times of the day, but the eye thing is, I think. But I think the context would do that. Sijui nyinyi mnaona aje? Something else.
N anauliza every other day.
Huh?
Ina mean abbreviation yake ikoje? N anauliza how is
Huh?
angalia kwa chat.
I'm
How
trying
is
to.
every other day abbreviated? I think niliona. Iko huko juu.
Ah. So for every other day, some will write like unaona venye tumeona, like if you're writing Q means every, so they can write every like the day for every day, or Q then 24 hours, like every 24 hours. Ama every other day is like every day. Ama ni every 48 hours. Sure kizungu.
Every other day is not every day. I don't think it's every. It's
Every
not
other
like,
day, it's every
yeah,
48 hours. Siku mbili.
Every
yes.
other day ni ile unayaule. So every other day ni QOD, then
Ruka.
every day ni QOD.
Ati nini guys? Okay, I've not heard.
Wacha ni type, internet yangu iko so
Every other day ni every 2 days. Hiyo itadenotiwa aje kwa prescription?
Yo, it was like Q, then 48H.
Oh, 248. Okay, every 48 hours. Okay.
Mm.
QOD.
On-
Unaona kwa chat?
Like that. Oh, QOD. Okay, sawa. Hapo, so either QOD or Q. Yeah, D or Q48H. Okay, I think I'm back. Am I? Okay. So now we do the other part, which is now, what was it? Weight measures. Yeah, so we just need to know the metrics, like the SI units of some of the things like weight, volume, temperature. Then we look at density and specific gravity. Yes, hata mnaweza tu niambia tu SI units ya hizo vitu, and then how we convert, then we do calculations. Ama mnaona aje?
Pardon, kindly.
I'm saying the next part is the one for calculations, but before we do calculations we need to do the units and the measurements. So ndio ninauliza aje hiyo units na measurements, si mniambie tu una mention a unit na unaniambia SI unit yake, then we see how to convert those the SI units to other units, alafu tufanye calculation. Unasema pardon. Letting SI units ya weight ni nini?
Kilograms, grams, micrograms. Hizo. Oh, SI. Ama gani hizo kilograms per hiyo meters per second.
Sijakusikia.
SI units ni hizo newtons, si ndo? Ama kilograms per meter second, ama ni gani hiyo unataka?
Oh wait.
It's kilograms.
kilograms.
Ama nimeenda
Hizo, but sasa now since especially for drugs you get like the weight of
kilograms, milligrams, micrograms.
for the weight of drugs, so they'll mostly use grams, milligrams, or micrograms. So then you'd need to know how to convert from whatever other weight to those ones. Those three are the common ones: grams, milligrams, na micrograms.
So unataka like values,
Huh?
like 1,000 grams make 1 kg ama una
It's
sijaget
okay.
hiyo swali. Ama like a conversion from pounds to kgs.
So SI mass ni kilograms, then ya nini ingine tunahitaji? Let me just open this book kidogo.
Na ya liters hizo liquids ama ndita nini?
Yeah, na ya liquids hizo liters. So ya liters at least ujue kuconvert to mls, and from mls and liters hizo zinatumika sana, but now for nini hiyo sijui sasa hiyo ni mass ama ni weight, like kilo za mtu ni mass ama ni weight, my guys?
Ya mtu
Kilo ya mtu inakuanga mass ama weight?
I think ni mass.
Ni mass, yeah. So now like those ones you at least know how to use from kilograms to what inaitangwaje, lobs or something, I don't know what it's called. Inaitangwa
Hiyo
lobs ama pounds.
Pounds.
Yeah,
Yeah.
because now you get like some of these countries that sitaki kusema wanajifanyanga superpowers, lakini they don't use the SI units, so then we expected to know how to convert to theirs and from theirs. Yeah. I think, but I think I've seen a question with such, but it had given the conversion factors. And then for temperature, yes, we use degrees Celsius, but again, you need to know how to convert to kelvins and from kelvins. And then I've also seen a question asking about Fahrenheit, to convert either to Fahrenheit or from Fahrenheit. So kutoka degrees Celsius kwenda kelvins unadu?
Ni ile ya kwa 273 ama ilikuwa 274 sijui.
Hiyo 273. So degrees Celsius ukiadd to 73, then you can convert to kelvins. And then for Fahrenheit, you take whatever degrees Celsius you have times 9/5, then you add 32.
Example.
The
Rudia
degrees
kindly.
Celsius, so una convert from degrees Celsius to Fahrenheit. So unachukua hizo degrees yenye umepewa kama ni let's say 10 degrees. So unachukua hiyo 10 degrees Celsius times 5/9. 5/9 unapata 18, then plus 32. Then whatever you get is now in Fahrenheit.
500, so plus 32.
Yeah. And then specificity tuone kidogo, then we go. And then when you're doing calculations, kumbuka Naomi akisema about significant figures, decimal places. Also, if you have a question that needs you to, let's say, give the answer to this number of significant figures, like 5 significant figures, then you only need 5 figures in your answer. Lakini wakisema, let's say to like, I don't know, to 4 decimal places, of course you count after the decimal place. If it's 5 and above, tulikuwa tuna add 1. If not, inaishia hapo your story. You just toa the other ones. And then, sasa kama let's say you're adding values that have different numbers of significant figures, and they need you to give your answer to the right significant figures. Unafanya to the one that has the least significant figures. Like, let's say you're adding 6.3 plus, you iko na 2 significant figures, 6.3 plus 4.13, and then plus another one. So you'll give your answer to the one that had the least significant figure. So 6.3 itakuwa na 2 significant figures. You give your answer to that significant figures. If you asked about hizo mambo za significant figures. Ninatafuta. Okay. Just give me 1 minute. I open something here. But basically for units, weight, measurements, ni hizo. And then sasa if you're, let's say you're supposed to calculate anything, let's say it's the mass, volume, depending on what you're given, you can always use a formula to calculate. But personally, me and formulas don't do very well. So sometimes actually, sitaki kusema logic works, but sometimes inaweza work. Yeah. So then we do density and specific gravity. So density ni mass per unit volume ya kitu. So yeah, then you express it in grams per ml, but again, saa zingine utapata it's not in those units. So if the question you have can work without, ni sawa. If not, then you have to convert the units ndio upate what is required. Then for specific gravity it's a ratio. It's a ratio expressed decimally of the weight of a substance, the weight of equal volume of a substance chosen as the standard. So the standard is most of the time water, because we said water, the specific gravity of water is 1. I think, yeah. So now hiyo ndio inatumikanga kama the standard. So you just take the weight of a substance, then basically divide by an equal volume of water to get the gravity. But we'll calculate at least an example ya specific gravity. Nisiwape tu hapa stories zenye hazina mwelekeo. So basically, now this is the formula for calculating specific gravity. Weight of a substance divided by weight of an equal volume of water. So yeah, Hiral was telling us essential oils have specific gravities less than water. Ndio hizi hapa ma examples hapa za ma oils. Yes, they have specific gravities of less than 1. So yeah, water. Can do an example like this one. So if 10 ml of sulfate weigh 18 grams and 10 ml of water under similar conditions weigh 10 grams, the specific gravity of the acid will be, we've said, the weight of whatever you're calculating, the weight of your substance divided by the weight of an equal volume of a standard. And in this case, the standard is water. But now the good thing, again, the density of water is 1. So the volume and the weight inakuanga same. So yeah. Yeah, so now for these units and measurements, I think you just have to know, like units, the density, and you just have to know. But now once you know that, you can do your calculations vizuri. So what do you guys think? We start calculations. My guys.
There's a suggestion. We
Uh-huh.
take a small break, then we continue. 5 minutes, 5 to 7 minutes.
So we start at like what's 11:15? Am I 11:20?
Yes, even 15, I guess. Yes.
It's okay. Okay. Calculations, example. So mkuje kama mmezitafuta mahali ziko, then we do them.
Yes, Tano. Tongilet.
Sorry, mmeniita?
Ulikuwa right ile swali ya jana. Nakumbuka ile swali ya nani? Ya bioavailability.
Oh, hiyo ya nani extent of nani protein binding ama? Oh.
Hebu elezea aje.
Penye mlikuwa mnanipiga
Hey,
vita.
kijana.
Ndio mnatuelezea man.
Calm down, ladies. Nilikuwa na point.
All right, let me read for you the whatever.
I think Sonia alikuwa ame screenshot. Sijui kama ako nayo. Sawa, kama
Walituma.
uko nayo sawa.
Yeah, so they're saying the extent of drug binding, specifically to the plasma proteins, can influence the distribution of a drug in the bloodstream. But generally, this doesn't have a significant effect on its bioavailability, since by definition, bioavailability pertains to how much of the administered dose that reaches the systemic circulation unchanged. That's after absorption from the site of administration, the target site. Yeah, and then they go on, and then they're saying that the other factors, that's formulation of the drug, hepatic impairment, and gastric emptying. they can directly impact the process by affecting absorption, metabolism, and elimination. However, the extent of protein binding primarily affects distribution of the drug within the body, but
Yes.
doesn't directly affect how much of the drug is available
Yes.
for therapeutic action or
Thank you,
execution.
thank you, thank you. Nzuri
Thank you, Prof. Thank you, Prof.
influence.
Yeah, you're right.
Nani
Mbona
protein
walikuwa
binding is more
wanakushuku?
of the- yeah, nani mmoja hapo alikuwa ananipigia kelele.
Sasa unataka kulia.
Mwambie kule humble pie.
Yeah,
Ai,
ninafurahia. Yeah, but nani protein binding, it's more of the distribution aspect rather than availability. Although in affect availability, but it's not that much. Thank you for that research, sir.
Asante. Guys, we continue, Ama.
We can continue.
Okay. So we can start from, I think, here. We do some examples, at least what topics we need to maybe at least do more of. Then we can choose the specific one from the textbook, and then you can do them. So for the first one, question 96, 300 parts per million as a percentage strength is. So parts per million, exactly as it said, it's 300 in a million. And then when we are converting to a percentage, of course, we need to find that in 100. Yeah, so it's just 300 over a million times 100, so that you can convert that to a percentage. So parts per million, it's in a million. You can get parts per billion and such. So you can always convert them now to other units. So if it's this, the parts per million doesn't have like other units. You see, like for example, the way in percentage now, like this one, what we've calculated, like we get 0.03%. Then they say it's, let's say, weight by weight, weight by volume. So if it's weight by volume, or yeah, those grams in 100 ml of solution, then that's weight by volume. So those grams in 100 ml solution, or if it's weight by weight, it's those grams in 100 grams. That's what percentage concentration is. Yeah, then if I need to, I don't know, write or something, you guys can tell me if we get somewhere and maybe I need to write or explain something. And then the next question, what percentage is produced when 150 milligrams of powder is made up to 25 grams with a diluent? So basically we are diluting a powder from 150 milligrams of powder. We are diluting it to make 25 grams. So like I was saying, these are two different units. So first, you need to convert the units to be the same, either to milligrams or to grams. But now, yeah, but then the question is asking what, yeah, so basically we can just convert either 150 milligrams to grams or 25 grams to milligrams. So from milligrams to grams, the conversion factor is what, 1,000. So if you're converting milligrams to grams, you divide by 1,000. If you're converting grams to milligrams, you multiply by 1,000. Yeah. So then basically it's just, yeah. So if 150 milligrams is in 25,000 milligrams, and we want to calculate the percentage strength. So we are calculating about in 100 grams so that we can get the weight. I need someone to be calculating for me, my guys. Alafu mnaniambia kama tunaendelea vizuri.
Tuko sawa.
Sawa. Yeah, then they're asking the next one is what volume of normal saline? 0.9% weight by volume. So again, so they're giving us the concentration in weight by volume. So this basically means 0.9 grams of normal saline in 100 ml of solution. So they're asking how much of like what volume of normal saline can be made from 0.5 grams of sodium chloride. So again, we know 0.9 grams is in 100 ml. So if you have 4.5 grams, how much volume would you make?
Yeah, iko sawa 500.
Iko 500. So you can either fanya hivyo ama you can, yeah. But pia guys, if whatever question we are discussing, there is a simpler way, like an easier, a faster way of doing the question, tafadhali mzilete so that we don't go in the exam and spend a lot of time doing calculations na kuna mtu hapa ako na simpler way. Yeah, so you see, like in this question, they have told you the volume of normal saline, then they have given you in brackets 0.9% weight by volume. So sometimes they will omit that part, the one in brackets. So saa zingine tu wana assume wewe unajua normal saline inakuanga aje. They assume, sometimes they might assume unajua. Then the next one, what amount of digoxin is contained in 100 milligrams of the following powder mixture? So the mixture has 100 milligrams of digoxin and 900 milligrams of lactose. So the whole powder is 1,000 milligrams. So my guys.
Yes.
So then you can just either just do the ratios or divide, yeah, to get how much is in that 100. So like 100 milligrams is in 1,000 milligrams. So what about in 100 milligrams? Then you get 10 milligrams. Then we can also look at this one. A start dose of 35. So this is micrograms. But sometimes instead of writing micrograms like this, they'll use that car, I don't know what it's called. That's U that looks like it has a tail. Yeah, so they might use that to mean micrograms here. So a start dose of 35 micrograms per kg of drug X is ordered for a patient whose body weight is 100 kilograms. So how much drug should be dispensed? Okay, so we need to, we need to give 35 micrograms per kg and our patient is 100 kilograms. So tunampea dawa how much in micrograms? So it will be 30 micrograms times 100. So that we need to give the patient 3,500 micrograms of drug X. But then kwa majibu, it's in milligrams. So again, we have to convert from micrograms to milligrams. So from micrograms to milligrams, we'll divide. Let me just send Chaniwa to me a table here that shows those conversion units so that you can know how to, if you don't. Multiply with or divide with to get the other units. And then the picture also has the SI units for the base units. But I don't think we need to know base units. But yeah, base units you just have to measure to get them. And then kuna hizo zingine kina derived units, those ones you can measure something else, then derive them kutoka huko. So we had 3,500 micrograms. You divide by, from the table I've sent, or from chenye mnajua, na divide na ngapi from micrograms to milligrams. So we divide by a million or 1,000. From micrograms to milligrams, we divide by 1,000. Yeah, micrograms to milligrams, we divide by 1,000 to get 3.5 milligrams. Then how much of a product is required to make 1 liter over 1 to 1,000 solution? So for percentage, ratios, proportions, now like if it's 1 to wherever, this is a solution, so it's mLs to mLs. Like 1 ml of something is in 4,000 mLs of the solution. And then we want to know how much of that is in a liter. So a liter is 1,000 mLs. So if 1 ml of that drug is in 400, how about in 1,000 mLs? Unapata ngapi? Whoever has done that. Anyway, so if it's solution, it's mLs per mLs. If there is like mass, it's grams in mLs, like in percentage. Weight by volume, the grams in 100 ml. Now volume by volume, ni mLs in mLs. So here it's yeah. So gram, the question, okay, the answers are grams. So it's weight in that volume. So if 1 gram is in 4,000 mLs, what about in 1,000 mLs? You get 0.25 grams.
Let me ask you, Seraphine. You've determined
Yes.
it's grams per ml because you've seen the choices, the answers are in grams.
Yes, but without the choices, I would just have calculated whether it's in mLs or whatever units. But of course, it has to be either volume or weight. So
Yeah.
1 is in 1,000, what about in 4,000, what about in 1,000? Then mimi ningeenda na jibu, okay, all the units are the same nini, so haina shida.
So
But
it's not-
unless they have said the mass of the volume, I don't
Mm.
think there's a way from that question we would have told it's in grams.
Okay, so
Manjari,
Yes.
who kindly repeat the
So the question asks how much of a product is required to make 1 liter of one is in 4,000 solution. And we said just like in percentage strength, kama ni weight by volume, ni grams in 100 mLs. Grams and mLs, 100 of them. If it's in volume by volume, it's 1 ml in 100 mLs. So basically, tunaangalia hapo units, either grams and mLs or yeah. Then hapa wametuambia 1 is in 4,000. So it can either be what, assuming we don't have the answers, itakuwa either of those. But basically, 4,000, it can either be 4,000 grams or 4,000 mLs. Those are the only two units it can have. We want to find in 1 liter. So we have to convert the 1 liter definitely to mLs. Hatuwezi convert to grams. So 1 liter to mLs tupate 1,000. So 1 iko in 4,000. What about in 1,000 mLs? Tukapata 0.25. Chai, kwa sawa?
Oh yeah.
Then the next one. A solution of potassium permanganate is prepared by dissolving 16 tablets of 0.2 grams in enough purified water to make 1,600 mLs of solution. What is the percentage strength of that solution? So like here we have grams and mLs. So basically we want percentage strength. Itakuwa in grams per 100 ml. Hiyo ndio itakuwa our percentage strength. So we have 16 tablets of 0.2 grams. So we do 16 tablets. So we'll do, what is it called? 16 tablets times 0.2 grams to know how much weight all of it has. We get 3.2 grams. 3.2 grams. I wish I could be writing lakini sijui hii mambo. Yeah, so we've said we'll do the 16 tablets. Okay, no, it's so big. Sijui kupunguza. That times 0.2, we get 3.2. So 3.2 grams. Then this 3.2 grams is in 1,600 mLs. But sisi tunataka in 100 ml because percentage strength, we've said it's that gram in 100. So what about in 100 mLs? So inakuwa 3.2 times 100 divided by 1,600. You get 0.2. Guys, tuendelee.
Yeah.
Ama tusiendelee, tuendelee.
So nataka kutuwekea concert sasa saa hii.
venye nafaa.
Okay.
Gas anasema anataka chai.
Na si amchukue.
Umeambiwa uchukue, ndo huyo Gas umeambiwa uchukue.
Hakuna kuongeiana hapa.
Okay. Then 500 ml of a 15% solution is diluted with enough, I don't know, for injection, whatever. It's just diluted to 1.5 liters. So, what is the concentration of the resulting solution?
Hizi tunatumia C1V1 ama? Ama sila C1V1 ziko tu C2V2.
So C1V1, this is CV is equals to this, and now the concentration. Sasa ungekuwa ukisema hivyo ukifanya.
Sasa siwezi type juu niko na kwa simu.
Oh, there's not a way I can do that. Sasa sijui hata kudelete yenye nimeandika hapa.
Si ndio hiyo eraser hapo hivyo.
Hiyo raba hapo juu, hiyo eraser. Hiyo next to draw. Mimi naniambia next to draw, na mimi natumia hapa laptop ya miaka ya mkoloni. Uzuri uko na content.
Si unapata nini? Unapata 5%.
Chai amesha calculate. You know my guys, if it's kama mna calculate, then itakuwa so much easier kujua venye kuna endelea.
Nimekuelewa.
So unapata the new concentration itakuwa hiyo 5. So you can use C1V1 and get your whatever. Yeah. Unapata ni hiyo 5%. Then the next one, 150 milligrams of a drug powder is mixed with 7.35 grams of powder L. What is the percentage strength of the drug in the total mixture? So, wamechukua 150 milligrams wakamix na 7.35 milligrams. That's the way like the mixture. So it's 7. Wait, kai moja ni grams, zingine ni milligrams. Sasa unaona hivyo let's not do that in the exam. So we need to convert the 150 milligrams to grams. So that 150 milligrams to grams inakuwa ngapi? Tano ni convertia
0.15.
So that's the whole weight of the whole mixture. And then they want to know the percentage strength of the drug. So we have 0.15 grams of our drug in 7. So, but in percentage strength, we want to know in 100 grams. Hey, what? No one is calculating. We've said if
Serafin ulikuwa
0.1.
umepotea for some time maybe.
Oh, so tumesema
Ulipotea.
to convert hiyo 150 milligrams to grams, tukaconvert tukapata 0.15 grams. Hiyo 0.15 grams is in, we added the two to get the mass of the total mixture, which was 7.5. So 0.15 milligram, not milligrams, 0.15 grams is in 7.5 grams of powder. So for percentage strength, we want to know how much will be in 100 grams of powder.
Ni 2.
2%.
Yeah, 2%.
We hizi calculation haziwezi. We
Umesema ati mbona ama si tungefanya tu 0.5
Ati?
divide 0.15 divide by 75 times 100. Hapo vile umesema ina 100 grams of powder umenichanganya.
Oh. Oh, tufanye 2%, hivyo percentage tufanye tu, okay. Yeah, pia that can work. Ni venye tu nilitaka kuemphasize hiyo percentage strength ni inamaanisha ina 100 grams of the powder. Ama kama ni ya weight by volume ni 100 ml of the solution.
All right.
And then the next one, how many total grams of lidocaine will be in a 300 ml of 2% lidocaine solution added to 300 ml of 5% lidocaine solution. So, tumesema percentage strength ni in 100. So like here, we have solution, but wametupea how many grams. So basically it's percentage, hiyo ni weight by volume. Sindio? So it means for the first part ya 300 ml of 2%, inamaanisha every 100 ml of that solution has 2 grams of lidocaine. Sindio? But guys, yeah, anyway. So,
yes.
Yeah, so sikujua how many milligrams iko kwa hiyo in 300, tutafanya tu 2/100 times 300. Then for the other one, 5/100 times 300. Then you add them. So 2/100 times 300, that is 6. Alafu 5%, so 5/100 times 300, hiyo inakuja 15. 15 plus 6, unapata 21%. 21 grams, I mean.
Anjani,
Yes?
hola, hebu kindly repeat. Yangu ilikuwa imelopa.
So we're saying For the first part, 300 ml of 2% lidocaine. So 2% ni kumaanisha 2 grams in 100 ml. So in 300 ml, definitely tutakuwa na 6 grams. As in, so itakuwa ni 2 over 100 so that we convert to mLs, not mLs, we convert to grams from the percentage. So 2 over 100 times 300 plus, now the other one, 5 over 100 times 300. So tukapata 21 grams. Then a pharmacist has been given 5 liters of a drug suspension and asked to divide it into equal number of 10 ml and 15 ml units dose dispensing cups. How many 10 ml dispensing cups will be used? So, anataka a divide into an equal number of 10 ml and 15 ml. So, anaeka 1, 10, 1, 15, and then the next one, 10, 1, 15. Until tuone tutakuwa na how many of the equal of them, like how many of those divisions. So for every one division, anaeka 110 ml na 115 ml. So one division anakuwa ameka inakuwa na 25 ml. So you'll just take 5 liters, convert to ml. Hiyo inakuwa 5,000 ml. You divide by 25. Mtu akiwa na formula ya kufanya hiyo hesabu, if there is an easier formula than that, please. Yeah, but we're saying, so we need to divide them into equal numbers of 10 ml and 15 ml. So how many of those do we need? So we need 10 plus 25, 10 plus 15, 25 ml. 5 liters, if you convert to ml inakuwa 5,000 ml. So 5,000 to divide na 25.
200.
Unapata 200. So we'll need 200 cups with 10 ml and 200 cups with 15 ml. Alternatively, I think we can tengeneza those things. What are they called? Simultaneous equations, 2 of them, and then you solve. Yeah. Anyway, but I think that's easier. Then the next one, aluminium has a gram atomic weight of 27. What would be the milliequivalent weight? So milliequivalent weight, to calculate milliequivalent weight, you need to do what? At least know the, what is it's called, the valence. You need to know the valence of your compounds. So valence ya aluminium ni ngapi?
I think 3. 3, ama?
Valence ya aluminium
3. 3 for 3.
Hi guys, am I back?
Yeah.
Oh, tulikuwa tuna calculate number 167. Aluminium has a gram atomic weight of 27. What would be the milliequivalent weight? So milliequivalent weight is equals to atomic weight divided by the valence of your compound. So aluminium iko na valence ya ngapi?
3.
3. So inakuwa, so atomic weight 27 divided by the valence which is 3, you get the milliequivalent weight ni 9.
Kindly rudia
Guys.
nani
Guys
hiyo
ameandika
formula kindly.
Milliequivalent weight is equals to atomic weight divided by the valence.
Asante.
Okay, alafu my people, mimi kuangalia chat sikumbuki, so mtaniambia tu kama kuna kitu I need to address huko kwa chat box. So the next one, an adult recommended dose of a drug is 5 milligrams per kg per day. So how many milligrams of the drug is required every 4 hours for a patient of 110? Okay, yani 110 mata sijui ni nini. Yeah, to assume 110 lobs body weight. So hiyo ndio tunafaa sasa kwanza, since the dose is in milligrams per kg, we need to convert this body weight to kgs. So 1 kilogram is the same as 2.2 lobs. So what about 110? So unachukua 110, you divide by 2 points. Hiyo. So 49, so then, so na tunampea 5 milligrams per kg. So we multiply your weight yake times 5. Let's say mpata ngapi? 248. Alafu, so anafaa kutumia 248 milligrams per day. Sindio? Yeah, 248 milligrams per day. But this drug is being administered after every 4 hours. Kumaanisha in a day anakunywa mara ngapi? 6. So you divide that, whatever you had, 248 divide by 6, ndio ujue after every 4 hours anakunywa kiasi gani.
41.
So 41.66 milligrams. So sometimes they'll give the conversion factors.
I think
Sometimes
hapo
they...
make two.
Huh?
Kama ni decimal points.
Umpata 41 points?
36. I think the
36.
closest ni hiyo 266.
Maybe again, hiyo story ya significant figures, sinaona kuanzia huko mwanzo. So if you start rounding off huko mbele, huko mbali, maybe you'll get 66. So hiyo story tu ya significant figures, I think. No, tuliambiwa oil in water emulsions. HLB values should be above 9. So 8 to 18. So you see calculation. Okay. So this one, if a drug has a plasma elimination half-life of 4 hours, how much of the drug present in plasma will be eliminated after 8 hours? My guys, kama mtu ako na formula pia ya calculate this question, I think it would be better. Currently sijatafuta moja, but maybe I'll look for it and send in the group. But in the meantime, we'll just continue doing what we've been doing. So the elimination half-life is 4 hours. So after every 4 hours, the drug is reduced, like the plasma concentration is reduced by half. So after 4 hours, once you take the drug, it's 100%, assuming everything goes to blood, 100%. So after 4 hours, tutakuwa tumetumia 50%, si ndio? Then in the next 4 hours, we'll again eliminate half of what is there. So we'll eliminate again half of the 50% that was remaining. So half ya 50 ni 25. So within those 2 half-lives, we'll have eliminated 2/3. Yeah, 2/3 of what is there, like 75% of your drug. Lakini currently sina formula, my guys. Diana?
So jibu ni gani, Seraphine?
75%.
Yes.
Uko na formula ya kucalculate history ya half-life? Letting Diana, Gaius, umeenda wapi? Someone. Tano uja tutafutia formula.
Mimi na Chenda tuwezi kuwa na formula.
Miss Hawking manze.
Sina
Mbona unatufikia? Hata uweze tutaja hapo.
Mazedi tuko sawa, haina shida.
Ni juu nyinyi ninajua mko na formula, so ninaita wenye wamekuwa hapa hivi wanalala tu nyuma ya
Hakuna kitu
darasa
kama
wanasema
hiyo.
hivi.
But ni sawa.
Sasa mlete hiyo formula. Because now it's much easier to do this question. Na hiyo sijui ni logic kama ni nini. Because it's only 2 half-lives. But now if it's more, itakuwa na tashwishi kidogo. Yeah, so tutatafuta formula ya kucalculate hiyo, then we see. Chai, wewe ndio unapiga hapa ma research watu wakienda kulala. Hebu tutafutie hiyo formula. Okay. So the next question.
Samiha.
Let's say you're saying something.
Yeah, kuna mtu anataka urudie namba. Ilikuwa 168 nani? Ya pounds hiyo. Sasa ndo sijui kama ako kwa meeting ama ametoka.
Confirm kama ako, then we go back.
Ako. Ndo hiyo ametext. I think ilikuwa number 160 something.
Okay.
Hiyo ya pound. Ngapi?
This one.
Yeah.
So the question says, an adult recommended dose of a drug is this 5 milligrams per kg per day. Then, so how many milligrams of the drug is required every 4 hours for a patient of 110? Umesema hii ni pounds?
Yeni.
Yeah.
Pounds.
Yes.
Anyway, yes. Then, to at least for this question, we've been given the conversion factor. So 1 kg is same as 2.216 pounds. So you mtu wa 110 pounds ako na how many kgs? So see, we take 110, we divide by these ones to get the number of kgs. So let's say, so we take 110, we divide by, so sio ndio kgs za huyo mtu. Na the recommended dose is 5 milligrams per kg. So tutampea how many milligrams? So we multiply 5 times the number of kgs to know the milligrams.
248.
So 248 milligrams per day. Sindio? So hiyo 248 milligrams anapewa per day. But wamesema hii dawa anakunywa every 4 hours. So in a day, then it means anakunywa hiyo dawa 6 times.
So divide by 6.
So we divide by 6 to get anahitaji dawa kiasi gani every 4 hours.
41.36. Amesema ako sawa.
Yeah, then here, 3 grams of iodine is in 150 ml of iodine tincture. What is the percentage of iodine in the, what is the percentage of iodine? So to convert to percentage, si tunafanya tu hiyo, what is it called? 3 over 150 times 100. Unapata that is what 2%.
Yeah.
Okay.
Sawa.
Then the next one, if an eye drop solution contains 200 drops in a 10 ml bottle, what is the volume of 1 drop of the solution? So 200 drops ni 10 mLs. 1 drop ni how many mLs? So that is so 10 ml
0.05.
divided by 200 drops, unapata how many?
0.05.
0.05 mLs. Okay. Kama mtahitaji between the calculations to make 60 mLs of the solution, what is the percentage of ethanol in the resultant solution? So ni kama tu, it's just like the previous one we've done. So inakuwa tu hiyo
I think ni net yangu ilikuwa nani, pole. Hiyo namba 60, namba 68 na 69 imesema jibu ni gani? Hiyo 68
huh?
Mnanisikia? Anasema 68 na 69, ulisema jibu ni gani? Do you think ilikuwa sikuwa nasikia at some point?
2% na 0.05 ml.
Oh, sawa, asante. Ni sawa, Serafin.
So standard number 68 na 69 percentage nini, what is it called? Percentage. What is it called? Percentage concentration. So hiyo ilikuwa ya weight by volume, in ya volume by volume. So if 15 mLs of ethanol is mixed with water to make 60 mLs of a solution, what is the percentage of ethanol in the resultant solution? So tunachukua 15 over 60 times 100 to get the percentage. So tunapata 25%. And then 0.3% weight by volume expressed as milligrams per ml is equal to, so we said for percentage concentration, it's grams per 100 ml. Alafu, hapa wanataka to convert your 0.3 grams in 100 ml to milligrams per ml. So 0.3 grams.
Itakuja 30.
No, inakuja 30. So 0.3 grams is in what? In 100 mLs.
No,
So,
ni
so 0.3 grams iko in 100 ml. So kumaanisha kwa 1 ml kuna 0
ni 300 mg in 100 ml. Ukiconvert 0.3 grams to
0.3 grams per 100 ml.
Zinakuja 300 mg in 100 ml. So ukifanya per ml itakuja 3 milligrams per ml.
3 milligrams. So you can either start from converting either side, or you can start by converting 3 grams is in 100 mLs. So 1 ml itakuwa na how many grams? Utapata 0.03 grams per ml. Then you just convert now the 0.03 grams to milligrams. So you get venye Letina amesema 3 milligrams per ml. So tunaendelea ama tunaenda break tena?
Tuendelee.
So how many? So how many milliliters of a 5% stock solution should be used to prepare 4 fluid ounces of over 1 is to 200. So 4 ounces. Kwanza, we need to convert those 4 ounces to mLs. At least we work with the same units. Ndio tuone. Conversion factor ya mLs to ounces ni ngapi? Acha msiba. Okay. It says 1 ounce is approximately 29 mLs. 29, wengine wanasema 30.
No, anasema kuna place ni 129.6.
Number 29.6.
So hiyo ni kama ni 30.
So wengine wanasema 30. I'm trying to figure what we should use.
I think
But
we can use,
so we use, huh?
we try with 30 and 29, then we see tutapata answer.
We use 1 ounce is equals to 30 mLs. So 4 ounces.
Then we use
So 4 ounces itakuwa 120 mLs. So how many milliliters of a 5% stock solution should be used to prepare 120? So it was 120 mLs of a 1 in 200 solution. Yeah. So yeah, 1 in 200, it's like 1 ml is in 200 mLs. So basically, yeah. So okay, convert like to get the concentrations, utafanya, yeah, what is it called? Hata sijui ninasema nini. Anyway, but anyway, 1 ml is in 200 ml.
ml.
So sisi tunataka kujua how much we need, how many mLs we need to make our 120 ml. So tunapata ngapi?
Tunapata 0.6. Tunapata 0.6 ml.
0.6 mLs. Okay. Now we need to figure out ni wapi nimewadanganya.
Hizi nini watu wanaandikiana hapa kwa juu?
Okay, so let's start now. I'm back officially. So stock solution ni 5%. Sindio? So 5% inamaanisha ni 5 mLs is in 100. Sindio? In 100 ml of solution. That's that's our stock.
Yeah.
Then what we want, tunataka concentration ikue 1 ml ikue in 200. That's what we want. But then we want, instead of 200, we want ikue mingi, we want it to have 120.
Like, so the question is how many milliliters of a 5% stock solution should be used to prepare 4 fluid ounces. So from E4 fluid ounces, we've gotten 0.6 ml. And then our stock solution is 5 ml is in 100. Now what of preparing
0.6
this?
mL?
Yes. So that we find the ml of this 5% stock solution. How much of that should be used to prepare now your 4 fluid ounces?
0.6 times 100
Divide by 5. Nakuja 12.
Haya, Diana elezea sasa vizuri bila breaks your calculation.
Sasa hii calculation, the question is how many milliliters of a 5% stock solution should be used to prepare 4 fluid ounces of a 1 to 200 solution? So the first thing we need to do is understand that the stock solution is 5 ml is in 100 ml, like 5 ml of whatever that is in 100 ml. Now we need to know how much of this stock solution should be used to prepare 4 fluid ounces of a 1 to 200 solution. So we first convert the ounces into ml, where we've discovered that 1 ounce is in 30 ml. So what of 4 ounces, you get 120 ml. Then we say 1 ml is in 200 ml of solution. What of 120 ml? We get 0.6 ml. Then we say since 5 ml is in 100 ml, how much is 0.6? Then we got, of course, 12 ml.
Ngoja. Rudia tena.
Irudio. So first, we converted the 4 ounces to ml, where we said 1 ounce is in 30 ml. So unapata 120 milliliters. And we want to prepare 4 ounces of a 1 to 200 solution. So we say 1 ml is in 200 ml, what of 120 ml? Then you get 0.6 ml. Then we
Alafu,
and then see it's asking how many milliliters of a 5% stock solution. And when it's 5%, we know it's 5 ml in. It could be 5% volume by volume. So 5 ml is in 100 ml. What of now our 0.6 ml in this stock solution? Then you'll use 12 ml of the stock solution to prepare now the 4 fluid ounces.
okay. Thank you.
Okay.
So the boiling point of alcohol is 78 degrees Celsius. The corresponding temperature in degrees Fahrenheit itakuwa ngapi? So tulisema unachukua degrees Celsius times 9/5 plus 32 unapata Fahrenheit. And then for temperature, the what is it called? The SI unit for temperature is kelvins.
Seraphine, should we stop maybe? If you're tired, then
That's the next one.
Seraphine,
Your Lennox in pediatrics. Yes.
are you tired? Like we can continue with it. Like with calculations, I'm sure we can't like exhaust them in one discussion. So
Yeah.
we can decide.
Sasa,
Mhm.
no, what did you want to say we do?
If you're tired, we can stop. Then after chai is done at night, then we continue with the calculations. Then we'll be doing calculations. Oh, you said at night you can't.
That's nice. But Pia, now the good thing is, since we've
Mhm.
done calculations from I don't know how many papers now,
Mhm.
we have at least done a sample of every, sitaki kusema everywhere they can bring a calculation, but we've done most of it.
Mhm.
So then tunaweza malizia hii page, alafu hizo zingine maybe mtu anaweza angalia if kuna yenye inakaa hivi kuleta tashwishwi kidogo, then we can do those ones.
Yeah, or we'll just be doing them after in the night session. We can just we can dedicate ourselves, maybe we do a few pages. Yeah, so okay, so
So then we can
Sasa
just
tunafanya kazi
malizia
poa sana.
hii. Okay, zimekuwa mingi. No, we can finish hizi za hapa kwa hii page. Tunaweza malizia hizi zenye ziko hapa kwa hii this page, then we tuachie hapo.
Okay.
We call it whatever we
Hii
call
paper
it.
iko na bado maswali ngapi? Si tunaweza maliza hii paper. Hii like hii specific one.
Tunaweza
Ama ni mingi sana.
endelea
Kama
usiku,
kuna gas.
like usiku after chai ametupitisha partition coefficient, we can be doing the calculations. Pia Seraphine asichoke sana.
Yes, Seraphine ameongea mazee from 10. Hadi
So,
na Seraphine nikutumie soda madiaba.
hebu nitumie soda madiaba kwa sababu I'm the only one who understands what that means. But pia if we use again part of the evening discussion to do calculations, pia pharmaceutics nayo ni kuna venye iko na content, so maybe I don't know, I would say tumalize hizi ze tunafanya sahi, then hizo zingine we can, I don't know, maybe we can do once we are done with pharmaceutics, when we're going through the papers, tumalize content kwanza. But tutajua ikifika jioni. Shai will let us know.
You will get to appreciate that aspect.
Anyway, Lanoxin Pediatrics Elixir contains 0.5 milligrams of digoxin per ml. So how many micrograms are there in 3 ml of the elixir? So unaweza convert your milligrams sai to micrograms ama calculate kwa 3 ml in milligrams alafu convert back. I don't know, whichever you choose to do. So 0.5 milligrams is in 1 ml. So in 3 ml, tutakuwa na ngapi? 0.15 milligrams. Then now you convert 0.15 milligrams to micrograms. Unapiga hapo multiplication yako na 1000. Unapata 150 micrograms. Yeah, so micrograms, they can either write, though you hata inakaa M. That's U ama MCG, yes. Either of them can be used to mean micrograms. Hii yao wenye wameandika hapa yenye hata sioni ni nini. Anyway. Then strong iodine solution contains 5% weight by volume iodine. So how many milligrams of iodine are consumed daily if the usual dose is 0.3 ml TID? So tumesema TID ni nini?
Mara tatu.
Mara tatu. So 0.3 ml times 3. So kwa siku wanatumia 0.9 ml. Si ndio? Na
Yes.
100 ml of that solution, 100 ml has 5 milligrams. So 0.9 ml ziko na milligrams ngapi?
Unapata 0.045 grams.
Correct. Inakuja 45 mg.
Sufficient water is added to 800 ml of a liquid chemical whose density is 0.8 grams per ml to make a final volume of 4,000 ml. So what is the percentage weight by volume concentration of the liquid in the final preparation? So, so 800 ml of that liquid chemical was added to make 4,000 ml. So 800 ml iko kwa 4,000 ml. Kwa 100 ml, because we want to do percentage concentration. Percentage concentration is always in 100. So kwa 100 ml, kutakuwa na how many ml of that liquid chemical?
Pole.
800 ml is in 4,000 ml. So 100 ml itakuwa na 20 ml of the liquid chemical. So 20 ml of the liquid chemical na density yake ni 0.8 grams per ml. So what's the hiyo 20 ml ni grams ngapi?
Hebu rudia tena.
Venye Seraphin unaiweka hadi ni kama nitaenda Mathare.
Oh, si ungesema hivyo. Okay. Clearly we needed that break. So we are saying 800 ml of that chemical iko kwa 4,000 ml ya solution. Na tunataka tujue percentage concentration. We said percentage concentration is always in 100s. So 100 ml ya solution itakuwa na how much of these? Itakuwa na how much of the, what is it called? So
Ngoja.
100.
Ni sioni ama
Huh?
mbona
Boku
sioni
mnasema
vitu?
aje?
Mimi peke yangu
Oh, ni
sioni.
iko sawa. Ni wewe ndo uone. Maybe internet ama?
Oh, I think so.
Sasa wenye mnaona tunahitaji how many ml of that liquid chemical?
Ni 40 ama 20?
Oh, 20. 20.
Oh,
So we need 20
Zaeb.
ml.
Mm.
Na density yake tumepewa ni, what is that? 0.8 grams per ml. So 20 ml weight yake ni ngapi?
16.
16.
Sweet 16.
Sawa, Diana, who is sweet 16? Okay, nitaki kuisha na hata mimi sasa ninataka yeah. Then how many grams of 2% aluminium paste must be mixed with 10% aluminium paste to prepare exactly 120 grams of 5% strength? So tunataka how many grams of 2% aluminium paste must be mixed with 10% of aluminium paste to prepare precisely 120 grams of 5% strength. Kama mtu ako na an easier way of doing this question, please let me know, kwa sababu hapa ndio tutaendea break after this question. So we need to add, let's say what, X grams of hii 2%, tuongeze Y grams of the 10%,
Tuweke 0.2x ama?
Then tutapata 120 milligrams.
0.02.
Nimeandika sasa. Yeah. So we can do that.
You can do 0.02x plus 0.1y, maybe.
Yeah. So Diana says 0.02
Ni guesswork.
x
X plus 0.1y.
0.
Is equals to 2400. Tuone kama hiyo
Sasa
itawa.
sijui nimefanya nini. I don't know how to return the box here. Diana.
Oh, but si wanataka
Kidogo.
a total of both. So haiwezi
Yeah.
kuwa x and y. It has to be x and x. So tutaona.
Diana,
Andike kwanza. Ngoja tu kwanza.
we can continue writing what we are saying. So we are saying if we have
Wachia tu hapo. Wachia tu hapo. Just wait there kwanza.
iko sawa because whatever we were doing tungeendelea hivyo, then we would have two equations, simultaneous equations, we solve them.
5 grams equals to 100 total.
Diana, mbona sio 2x plus 5x?
Kwa sababu hiyo the 5 and the 2 is in hiyo 2% is in 100 grams of the paste, but then we don't know exactly how much we need to add. Tukisema 2 peke yake
2x
then itamaanisha
5 na 10.
or tutumie 2, 10 na 5. Yeah, we can also use that. Diana, tuandike sasa.
Hapana, imeharibika. Wacha tujaribu tena sasa a different way.
Imagine we can just
Inaweza
write what we
haribika
were saying.
Aya,
We were
hebu
saying
sawa.
if we take x grams of the 2% to add y grams of hiyo ya 10%, then tutakuwa na 120 grams.
Yes.
And then
Ama si kwa x plus x cause okay, ni sawa tu.
and then the other one was what?
So and then your x ni 2% na hiyo y ni 10%.
Okay, nimepotea. Poleni my guys. Then if we take hiyo venye Diana alikuwa anasema 0.02 x plus the other one was 0.1y, tutapata 0.5 times 120 because already tunajua grams yake ni ngapi. Ndio 0.05 times 120. So they want how many grams of 2% must be mixed with, yeah, how many grams of 2%. So basically we want to find the x. Ndio. So but then so to solve, so hapa we write y in terms of x for this first part, ndio ikuwe y is equals to 120 minus x. So kwa hii equation we can replace y na hii 120 minus x. One 120 times 0.05
Ni 6.
6. Then now we solve for x for that last equation.
Okay.
Na mtu kwa chat amesema urudie Seraphin.
It's okay. Acha tumalize alafu
Acha
we
kwanza
start fresh.
unajua inakuja negative.
Nakuja negative.
Aha.
Nimepata, ngoja yangu itatokea positive. 1 second.
Nimeona Diana, ni negative. Yeah, it's giving a negative answer.
Tutafanya, wacha tuweke chat.
Nimepata y kama 30.
Y kama 30.
Sasa
So kama y ni 30,
kuja
yeah, hii ni kama itabidi tumefanya hii hesabu jioni. Ni kama imesahaulika. Or I can just check somewhere.
Wacha
x
kidogo tu.
inakuja na y yangu ni 30, x ni 90.
Huyu
X yako ni
amepata
7.
x 75. How?
Humo hesabu.
Hii itatoka negative. Okay, itabidi my guys I sit down and do this nicely.
Kwani
Okay, unaweza
masomo
tuma picha ya
online?
calculations yako.
ChatGPT imenifanyia ile kitu.
Mhm.
So venye tu how we were doing x plus y is equals to 120.
Mhm.
Then we also did 0.02x plus 0.1y is equals to 6. Si ndio?
Mhm.
Okay, yenye tu sielewi ni how walitoa hiyo negative. Cause they're saying, but when we do e 0.02x plus 0.1 times 120 inakuja 12. Okay, here wanasema the mass of aluminium.
Diana, si negative. Sisi ndio tulichokea mapema sana. 0.02x minus 0.1x is equal to, hii side ingine pia ni negative 6 minus 12. Poleni my guys.
Inakuja 6.
So hapa unapata ngapi?
No, but bado ukifanya 0.02 minus 0.1 itakuwa negative 0.08. Alafu 6 minus 12 itakuwa negative 6. And then so ufanye 6 divided by 0.08 upate 75. Yes, ni ukweli.
X equals to negative 6.
Then you divide both sides by
You divide
your
both side by
negative.
negative 0.08. Unapata x. Ni
Yes,
hiyo 75
75.
degrees.
Yeah. Ni kuchoka tu kumbe.
So anyway. So swali inauliza how many grams of 2% aluminium paste must be mixed with 10% aluminium paste to prepare exactly 120 grams of 5% strength. So we have one paste 2%, hiyo ingine 10%, but what we want is 5%. So how much of each do we add? So tunajua if we take x grams of 2%, we add to y grams of 10%, we should get 120 grams in total. So that's how we came up with our first equation. Tukasema if we take x grams, we add y grams, we should get 120 grams. Then in the next, what is it called? In the next equation, so see, we're saying we need 2%. Now 2% need 2 grams in 100 of the whole thing. Sindio? So how much, how much of the active is there or something like that. So ndio tukafanya hii 0.02x, like we did 2 over 100. Ama we can do what Letting was saying. We do 2%, we need x grams. So 2x plus ya 10, we need y. So tufanye 2x plus 10y is equals to 120 times 5. So that's you come up with your 2 simultaneous equations, then you solve them. So hapa wanataka tujue how many grams of 2% aluminium. So that's why in my equation, I was trying to eliminate y and to back in a x, which is for 2%, so that we don't have again to start minusing. So oh, it's one, my guys. Ni kama tutawachia hapo, but now for the other questions. Okay, we can finish hizi
We
za
can do them, at night.
yeah, but tunaweza fanya hizi za hapa sai. These ones,
So,
the 4 of them. So a pharmacist has 50 ml of 5% gentian violet. And then what will be the final ratio strength if the pharmacist dilutes this solution to 1250 ml with purified water? So akona 50 ml of 0.5 gentian violet. So 0.5 ml is in 100 ml. Sindio? Hiyo ndio, that's what that 0.5% means. 0.5 ml is in 100 ml. But yeye akona 50 ml of that solution. Kumaanisha actually hata hana 0.5 ml, akona half of that. So akona 0.25. So then 0.25 is diluted to make your 1250 ml.
Vanessa Rafin, umesema aje ati hiyo 50 ml
Tunafanya hiyo peke yake. Tunafanya that only one question and then we go for lunch, msijali. So what I'm saying is
so ni 5,000.
0.5% sinamaanisha hii gentian violet akona 0.5 ml iko kwa 100 ml of the solution, si ndio?
Yes,
But huyu pharmacist akona only 50 ml of this solution.
akona 0.25.
So kumaanisha 50 ml atakuwa na half of this one. So atakuwa na 0.25 ml. Hii 0.25 ml ndio amedilute ikakuwa kwa
1250.
So now they're asking now what is the final ratio basically. So
So inakuwa 1 to 5,000.
inakuwa 1 to 5,000. So ukidivide both side by 0.25 ml, 0.25 ml, unapata 1 to 5,000.
Serapin, tunaweza fanya ya Fahrenheit. Naona this is the second time wanaulizia about degrees Celsius conversions. Hiyo number 218. Then we can start from 216 usiku, because yeah.
So here,
Yeah, just
negative
that
12
one.
degrees Celsius is equivalent to how many Fahrenheit? Tulisema unachukua degrees Celsius, unafanya times 9/5, then whatever you get, you add 32.
Mlisema lini?
Leo tena twice,
nilisema leo mara 4.
na tukasema SI units ya temperature ni kelvins.
But sir, if you do that, your answer iko hapa. See, you've said 12 times 9 divided by 5
Yes. Umepata ngapi?
plus 21.6. Oh, negative 12. Never mind.
Okay.
So on 10.4 as well.
Sawa sawa, my guy. Tukaachia hapo. Alafu hizo
Tutaendelea.
maswali zingine nataka nitufanye hizi mbili ziko hapa katikati.
Ai, tufanye pepa yote. Wewe ni jokes, watu wamechoka, hadi watu wanasema kwa chat box wamechoka.
Goodbye.
Yeah, so
Thank you, Seraphine.
sawa sawa, kwa herini. We'll do the others. Sijui tukimaliza hii pharmaceutics.
We,
Thank you.
hiyo time watu watakuwa wanatumia degoxing sasa.
Haya.
Yeah. Nani host aate kurecord.
Seraphine.
I know you're saying something.
Umeambiwa ati uache kurecord.
Ni mimi na record?
Eh,
Wewe ndio
For sure.
wewe ndo host apparently.
allegedly.
Itabidi to do it, but
Approximately.
I don't think ni mimi.
Ani wewe though Seraphine, tunaona kwa participants wendo na record.
Okay, please uniambie basi nafaa kufanya.
Hapo okay, ama unaweza ni make host ni kunini, ama hapo chini kunafaa kuwe button ya ku stop recording or pause recording, click stop.